Good morning, folks. Looks like we're doing some continued work with the evaluation of categorical syllogisms. Today we're going to be talking about the rules method test for determining the validity of syllogisms. Folks, if you hear any other lectures about this, or if you look at any other textbooks on this subject, you may see that more than 3 rules are listed that have to be followed by valid standard form categorical syllogisms. Those lists are not incorrect. However, it is superfluous to break the rules down into more than 3 rules. Because the fact is, those other rules are merely derivable from the rules that I'm going to show you in just a moment. Now, it is already taken for granted before we use the rules method test that the syllogism is in standard form and that there are 3 statements. This is just standard for a syllogism. There are 3 statements, 2 are premises, 1 is the conclusion. We've already presupposed that the statements have already been placed into A, E, I, or O structures. And we've already presupposed, before we do any kind of testing, that there is reference to 3 categories or 3 terms, and that they're each mentioned twice in the argument, but not in the same statement. That is already taken for granted. Now, let's get to the 3 rules. The first rule, ladies and gentlemen, is what I like to refer to as the negation rule. Now, the reason we call it the negation rule is because it is a rule that pertains to negations. Now, for review purposes, there are 2 kinds of statements in categorical syllogisms that are negations. E statements, universal negatives or negations as they're called, and O statements, particular negatives or particular negations. Now, here's the rule. The same number of negations found in the conclusion must be the same number of negations found in the premises. I'll repeat it. The same number of negations found in the conclusion must be the same number of negations found in the premises. Now, the total number of negations that can be found in the premises, because remember, folks, it's only 1 statement, can be 1. So the conclusion will either have 0 negations or 1 negation. Now, if you apply this rule, what you know is this. If both of your premises are negations, you can automatically know that the that the argument is invalid. Because at most there will be 1 negation in the conclusion, and if you've got 2 negations in the sum of the premises, then it's not the same number. Now, some extended lists will say you can't have 2 negations as your premises and have a valid syllogism. Well, that doesn't need to be broken down any further because it's implied right here. Now, folks, if your conclusion is a negation, one of your premises has got to be a negation. In other words, If your conclusion is a negation and both of your premises are affirmations, you can automatically know that it's invalid. Now, this rule alone basically suggests that a whole range of possible syllogism structures are what? Invalid. There's a whole lot of possible syllogism structures that are invalid, demonstrated because of the negation rule. Now, before I talk about the next two rules, both of the following rules pertain to a concept called distribution. If any of you looked ahead to try to do any research on these rules ahead of time, you probably came in contact with this concept of distribution. Now, folks, I will be brief about what the concept of distribution means. For our purposes, you won't have to understand it, but you will have to be able to memorize and apply. The concept is really not a difficult one, but it is one that sometimes takes a little bit of time to sink in. Now, if a term is distributed, it means that all members of that class or term are being referred to. If a term is a distributed term, it means that all members of that particular term or class are being referred to. And each of the different kinds of statements will distribute different terms. And I'm going to give you a chart in a minute so you can remember what distributes what. But I will also be explaining to you why certain statements distribute what they do. Now, let's take a look at the A statement. All wombats are marsupials. We could have just said all W or N. It's really not relevant what the terms are, but I wanted to make it a true, true statement. You've seen this before. This circle's all wombats, this one's all marsupials. We got the intersection of the two right there in the middle. And we've already seen that the diagram of this looks like so. All wombats are marsupials. We are saying here that every single wombat is a member of the class of things marsupials. So we are talking about all members of the subject class. We are not talking about all members of the predicate class. We're not saying anything about all marsupials. This is why A statements will distribute the subject only. A statements will distribute the subject only. Next, E statements. No leprechauns are gremlins. Yeah, I can make this statement even though many of you would say there's no such thing as either. It's irrelevant whether or not these classes of things actually exist or not. Their concepts do. You've seen this before. This is how we would diagram the statement, no L or G. Now notice what this statement is saying. It's saying that there's not a single L that's a member of G, and it's also saying there's not a single G that's a member of class L. E statements will distribute both subject and predicate. E statements will distribute both subject and predicate. I statements some grasshoppers are flyers. They can fly. Some grasshoppers are flyers. I think that's a true I statement because I think some of them don't fly, some of them just hop. I may be wrong. I'm not the student of insect lore. Okay, some grasshoppers are flyers. We've seen this before. Some G are F. Now, folks, I statements will distribute nothing. They will distribute neither subject nor predicate. Why? Because we're not talking about all members of either class. All we have said is that there's some G that are F. And by the way, this also implies that some F are G. But we are not talking about all members of either class. So I statements distribute neither subject nor predicate. And if you wonder why I'm going into all this rigmarole, hold up a second. We will get there when we get to the rules. I'm merely laying the groundwork right now. All right, we've got O statements now. Some birds are not flyers. Penguins, that is some birds are not flyers. Folks, I hope that when I explained distribution for A, E, and I, there was nothing counterintuitive about it. Admittedly, the explanation of O's distribution for some people is at first counterintuitive. O statements will distribute. They distribute the predicate. Because what we're saying here is that this one or more members of class B are excluded from all of class F. So strangely enough, O statements are referring to the entire predicate. We're saying that this entire class of things is excluded from this one or more member of the subject class. So O statements distribute the predicate. Now, let's make a handy little chart, because remembering these things is a good idea. Kinds of statements. What do they distribute? A statements? Subject only. Thank you. E statements? Subject and predicate. I statements, no distribution. And finally, O statements, predicate only. Even if you don't fully understand the concept of distribution, not that I'm recommending that, you can still apply the rules method. Because really all you have to do is know the rules, memorize this, and then sort of do it like a cookbook. And I know that all of you know how to do that. Because many of your subjects that you have taken in secondary school, where you more or less had to memorize things, really taught you how to do this. You know, you can actually get things right without actually understanding them. Sadly, I went through a lot of my high school experience, being able to get nice grades, but not actually understanding. And that's partly because of the methods of teaching. But I won't go there. That's not the subject here. Anyway, you got this chart. There are two distribution rules. The middle term must distribute in one of the premises. The middle term's got to distribute. And here's the last rule that you need. If a term is distributed in the conclusion, then it must distribute in its corresponding, and I'm just going to abbreviate corresponding, premise. If a term is distributed in the conclusion, it must distribute in its corresponding premise. Now, hopefully, you have all of this down. Let's revisit a syllogism that we saw on a quiz just a minute ago, and I will demonstrate how the rules method would be used to demonstrate validity. Here we go. I'm going to put this one on the board and we'll run through the method. Remember we said, no G Rn. Then our next premise was some E Rn. And our conclusion was some E are not G. Now, I didn't ask you to do this, but let's work backwards here. The mood and the figure are E, I, O is the mood. And our figure, you'll remember, is 2. This is an EIO2. Now, it helps to have it written out like this when we're doing the rules method, particularly the distribution rules part. Now, when I'm doing this method, I'll start off this way. The negation rule. Does it pass the negation rule? The answer here is yes. Because we have one negation in the conclusion, and only one of our premises is a negation. So this one passes the negation rule. But of course, we're not done, because if it's valid, it's got to pass all 3 rules. Here are 2 distribution rules. The middle term. Does the middle term distribute? The answer is yes. Because the middle term is the predicate of an E statement. And E statements distribute both subject and predicate. So the middle term distributes. And folks, I may as well say this now. As long as one of your premises is an E statement, you can know for sure that it's going to pass this rule. It may not pass other rules, but it will necessarily pass the distributed middle term rule. Because one of these is going to be the middle term, and E statements distribute both subject and predicate. So if an E statement is one of your premises, it will pass this rule necessarily. Now the last rule is the conclusion. Do we have a distributed term in the conclusion? Yes, indeed we do. Because G is the predicate of an O statements. O statements distribute predicates. Now, if it distributes in the conclusion, it's got to distribute it up here. And guess what? It passes this test too. Because the distributed predicate in the conclusion is distributed in the premise. And the reason being, it's the subject of an E statement. Because it's the subject of an E statement. Now, I abbreviated there. Now, folks, the rules method is actually very easy to apply. But in order to use it, you have to go through all three of them to demonstrate that it's valid. If you see immediately that it breaks one of these rules, guess what I counsel you to do? Go straight to that and explain why the darn thing's invalid. For example, let me go for the easy one. If you see that somebody is proposing, let's say, an I1 syllogism, you don't have to go very far. Because all you have to do is say, I statements don't distribute anything. So it's going to be invalid due to what logicians call an illicit middle term. I don't mind if you call it an illicit middle or undistributed middle. But if you see your syllogism is proposed as this one, you know it's invalid right away. So the rules method actually comes in handy, because if you see that a rule is broken just by glancing at it, path of least resistance. I'll give you another one. Doesn't matter what the figure is. Anytime you see an EEE, you know it's not going to be valid because it breaks the negation rule. Or anytime you see somebody propose like an AAE is automatically invalid because you have one negation as the conclusion and you have 0 in the premises. So if you can see easily that a rule has been broken, well, the rules method, you just say, I'm not going to waste my time diagramming this thing because I see that it's broken the negation rule. It is therefore invalid. Now, I suggest that you review this, look back at some syllogisms that you've already done in the past with the Venn diagram method, and see how you do when using the rules method. And by the way, if it's valid or invalid, both methods should confirm the very same conclusion. If they don't, it means you've made a bookkeeping error somewhere. Yeah, if it's valid, it's valid. If it's invalid, it's invalid. And both of these methods are foolproof methods. If they don't get you the same result, it is a bookkeeping error. I hope this is demonstrated neatly how the rules method works, what the rules are, and a few examples for application. Cheers for now.